Go. Hello friends, today we are going to be going over chapter 14, problem number 41. And when solving this problem, it is very critical that you look at the diagram that is given, figure 14.19. So I'm going to have you take a look-see at that. But the problem states a certain alarm clock ticks 4 times each second, with each tick representing half a period. The balance wheel consists of a thin rim with radius 0.55 centimeters, connected to the balance shaft by thin spokes of negligible mass. The total mass of the balance wheel is 0.9 grams. And in part A, it asks us what is the moment of inertia of the balance wheel about its shaft. So, if we refer to our moment of inertia equations, we find that for this particular situation, we're going to be using I equals mr squared. And from the information stated in the problem, we have our mass and we have our radius, which allows us to just plug those two in and find our moment of inertia. Part B of this problem asks, what is the torsion constant of the coil spring? And in order to find the torsion constant, we need the torsion constant equation. Here's K, our friendly little torsion constant. And in order to find that, we're going to utilize our moment of inertia that we determined in part A, as well as our angular acceleration. So angular acceleration relates to our period with this equation 2 pi over our period. And that's a relationship between the angular acceleration being in radians and needing to figure that in revolutions. And in order to find our period, it's stated in the problem that the alarm clock ticks 4 times each second, with each tick representing half a period. So 1/4 of a second per tick times 2 gives us a period of 25 seconds. So using this information, we can now have all of our variables accounted for, and we can find our torsion constant by just plugging those in, and we find that it is equivalent to 4.3 times 10 to the negative 6 Newton meters over radians. And there we have it. There is our chapter 14, problem 41.